All right, example 4. Jasmine has $500 to invest. What annual interest rate compounded quarterly is required to double her money in 10 years in 5 years?
So this is going to be one of them solving backwards logarithmic type of things.
Yes, and we're still going to use
I'll be right back.
the same kind of formula that we've been using for example 3, but now we actually know what amount we want to get to, because how much do we have if we double $500? We'd have $1,000. So that means that A is going to be 1,000, P is going to be 500. We're trying to figure out what the interest rate will be. We're compounding quarterly, so when you think about K, you need to think about how many times do we get interest in a year. For quarterly, we would get it 4 times, so we put 4 down there. And then to the KT, we put 4 and then 10, because that's how many years we're talking about for the first time. We'll solve it once, and then we'll do it again by replacing the 10 with a 5.
Right. Remember, the KT part, the exponent, needs to be the total number of compoundings that occur while you're earning your money or doing your whatever.
Absolutely. So divide by 500 on both sides, and that gives us 2. And that should happen because we're trying to double here. Now let's think about how to solve this. What would you do here? This actually isn't necessarily a backwards logarithmic thing. Our variable's not in the exponent. We can actually do this a different way.
Yeah.
The 40th root.
Yeah, you could take the 40th root, and then what that does is it gets rid of that exponent of 40. Now, 40th root is not necessarily something we're going to, it's not something you think of right off the bat, typically.
Right. So on your calculator.
Okay, so what you're seeing right now on the side is the calculator, and we're showing you how you can use the 40th root. And there's 2 different ways to do this, and they're both pretty easy. So just, if you have some issues, just check out what we got going on the side. But it's not too hard, and I'll just punch it into my calculator right here also right now. So that would be the 40th root of 2. So 1.0175.
Shh, we're recording.
That was not a ninja-like escape either.
Why did I write 10 there? I'm sorry, that's supposed to be a 4. That's a 4 on the bottom. I just randomly wrote
4. So now go ahead and subtract 1 from both sides.
So that gives us
0.074 or 0.075
equals R over 4. So then you times by 4 on both sides?
Right, times 4. So I get 0.0699, and that should be our interest rate for this particular problem.
And we would change that to a percent.
Right, 6.99%, and that sounds like an interest rate that would work. Like if we got an interest rate of like 2,000.
That's a bad idea.
I would arch my eyebrow.
Yeah. So kind of running out of room here. All we do for the second one is you put 5 everywhere, where there's a 10 right here. And then you solve it the exact same way. And so what does that change? When we work it out, it just changes a few of the numbers that we multiply or divide or whatever.
Right.
So it's still
the same
4
process.
times 5. So instead of the 40th root, we're going to take the 20th root of 2.
Right.
And then after we take the 20th root of 2, we have to subtract 1. And you can work this out in detail if needed. And then after we subtract 1, we'll have to multiply by 4.
Right. So we're going to do all of that, and we're going to end up with 0.14105.
And that makes sense that would be a much bigger interest rate to have to
get to the same amount of money.
In half as much time, right?
Right. And basically, that's almost a doubling. It's a little more than a doubling, but that would make sense.
We almost doubled our doubling.
Right.
All right, now we're going to talk about compounded continuously, which is awesome for 2 reasons. One, in real life, that would be the ideal situation, because that means that every moment of every day you're earning interest, and that's getting added to your balance, and then you're earning interest on that balance. Because if you were to do a problem where you changed how often it was compounded, the more it's compounded, the more often, then the better that is. So, and it's not a huge change most of the time between them, but any little bit helps when it comes to money, right? So the other reason I think it's awesome is because it has like the simplest formula ever. A equals PE to the RT, or PERT, you could call it if you wanted to. So on example 5, suppose Scott invests 500 at 8.5% annual interest, compounded continuously. And this word right here is how we know that we're using this formula and not the one we've been using. So find the value of the investment after 1 year, 3 years, 8 years, 45 years, which this is all just going to be really easy plugging in, right? So the principal is 500. E is a button on your calculator, remember. The interest rate is 0.085, and then I'll leave this as T. What we're going to do is plug in 1, 3, 8, and 45 and see what that gives us. So get on your calculator, type 500, and then find the E to the X button over on the left side. Second LN is what it is on most calculators, and then put 0.085. We're going to do times 1 for the first one. And since this stuff is dollars, we typically want to round this to 2 decimal places, so because that's how many cents there are. So for 1 year, that gives us 544.36. Then just go up and change the 1 and make it be 3. So that gives us, welcome back, Mr. Hazelwood,
Thank you. Got distracted.
645.23. And then go back up and change that 3 to an 8. Did you just tweet me?
No, gotta try and do this. Oh, I didn't get it.
And then change the 8 to a 45.
Well, that was a pretty good picture. I don't know if you saw that.
No, I
Sorry.
didn't.
That's more like it.
We're just recording here, so that's okay.